Hello! In this video we will discuss transistors, how they can be used with an Arduino, and explain how they work. Transistors are divided into two basic types: bipolar junction transistors, BJTs, and field effect transistors, FETs. In this video we will mainly talk about bipolar junction transistors and more precisely about the NPN variant. Transistors can be used as electric switches or signal amplifiers, to name some examples. Transistors are widely used in memory modules and processors. A more practical use case is to control a DC motor's supply current. Transistors have three terminals called the collector, base, and emitter if we are referring to BJTs. They are accordingly called source, gate, and drain in FETs. The base terminal is the input for the control current or voltage and alters the current flow between the collector and the emitter. If the control signal is zero, the transistor acts as an open circuit and no current flows through it. When the control signal is high, the transistor acts as a short circuit and current flows freely. The key point is that the control signal can be multitude smaller than the current flowing between the collector and the emitter. We are now demonstrating how an external supply current to an LED can be controlled with a transistor using an Arduino. The current used by the LED is drawn from a 9-volt battery, and its flow is changed by the control signal sent to the transistor's base from the Arduino. To follow along, you will need an Arduino, a breadboard, a transistor, an LED, two 1000 ohm resistors, and some hookup wires. First, connect the transistor to the breadboard, then connect ground to the emitter, the control signal from pin 6 in series with a 1000 ohm resistor to base, and lastly, the LED to the collector. Connect the other terminal of the LED via a 1000 ohm resistor to the battery's positive pole. Remember to connect all the grounds together. Let's take a look at the code. First, the control pin is defined and its mode set. In the loop, we are using two for loops to vary the control signal between 0 and 255, and then using analog writes to send the value to the transistor. Remember to include small delays to prevent possible issues. Next, we'll take a closer look at how NPN-type bipolar transistors work. When we understand the working principle of them, we can easily expand to PNP types as well as FETs. An NPN-type bipolar transistor consists of two N-type semiconductors which are separated by a P-type semiconductor. Remember that N-type semiconductors have excess electrons and P-type lacks electrons. The base terminal is connected to the P-type semiconductor and the emitter and collector to the N-types. When a current is supplied to the base terminal, electrons start to move from the negatively charged emitter to the positively charged collector. The small current to the base terminal makes a big current flow between the emitter and the collector. A PNP type BJT has the types of semiconductors swapped. This results in the current direction and voltage polarities being switched. Otherwise, the working principle is the same. In a FET, the semiconductors are arranged slightly differently, but the concept of moving electrons stays the same. The difference is that the gate is not connected to the P-type semiconductor, but instead it creates an electric field that allows electrons to flow between the terminals. The most common field effect transistor is the metal oxide semiconductor, MOSFET. That's everything for this video. Thank you for watching and see you in the next one.